We know that exercise and improving fitness plays an important role in health and also performance in the heat. But just how much does fitness improve work capacity, and how does it change depending on temperature? In today's episode, we'll explore a study testing and modeling how much work people of different aerobic fitness can do at different temperatures, and how this might impact worker productivity and health. We know that there are many benefits of exercise to our physical and mental health. One question is whether being fitter directly improves our ability to exercise or work in the heat. In 2001, Selkirk and McLellan tested the separate and combined effects of both aerobic fitness and body fatness on exercise tolerance in soldiers wearing chemical warfare clothing in the heat. This was done by a unique recruiting design where they tested fit and non-fit individuals with either high or low body fat. This was challenging because of the relative scarcity of fit and high-fat individuals and non-fit and low-fat individuals. What they found was that fit and low-fat individuals lasted much longer than any other groups, whereas body fatness had only a minor protective effect on exercise in the heat. That study was very influential, but it only provides one snapshot of the effects of fitness at one individual temperature and while wearing heavy protective clothing. That makes it hard to generalize to whether the benefits are the same at all temperatures or conditions. In the case of workers, it also makes it hard to actually implement strategies such as how much to adjust workloads based on worker fitness and ambient temperature. To address this, Foster et al. In 2021 tested 19 young, healthy males who were of either high, moderate, or low aerobic fitness. The test consisted of walking on a treadmill for an hour, with the speed and elevation adjusted so that the heart rate remained at a constant 130 beats per minute. The main variable of interest was how much overall work they could do in that hour while maintaining that constant heart rate. This was repeated at a range of conditions ranging from 18 to 40 degrees Celsius wet bulb globe temperature, an index which combines both temperature and humidity. Once all the testing was done, Foster modeled the results for a theoretical high and a low fit individual, with VO2 max values of either 60 or 40 milliliters of oxygen per minute respectively. This was done across a range of temperatures from 15 to 45 degrees Celsius wet bulb globe temperature. Their physical work capacity was compared relative to how much work they performed at the coolest temperature condition being set at 100% on the vertical axis. Not surprisingly, both the fit and non-fit individuals had decreased work capacity as ambient temperature increased. In the bottom in pink is graphed the difference in work capacity between the fit and the non-fit individuals. We can see that the gap between the two groups differ based on temperature, with the gap biggest between 30 to 35 degrees Celsius, and then it spreads out to be less at both lower and higher temperatures. Of course, the biggest gap occurs at the very typical temperature values that we see during summer in temperate countries and in many equatorial countries throughout the year. As we noted at the start, physical activity and fitness is important for all aspects of human health, and it is not just about work productivity. However, what this study tells us is that a fitter worker is a more productive worker, who would also be better protected against heat illnesses while at work. This supports studies showing that healthier and fitter workers generally also have less absenteeism. Also, if individuals are less stressed while working or in the heat, they are also likely at lower risk for accidents. The importance of this study is that it provides a clear rationale for industries to promote worker fitness, and also helps in planning workload according to individual characteristics and environmental conditions. Hopefully this video doesn't leave you hot and bothered. I'm Professor Stephen Chung, and I run the Environmental Ergonomics Lab in the Department of Kinesiology at Brock University. We post new videos on different topics in environmental physiology every Wednesday. Thanks for watching. We'll see you next time.